July 16, 1943, 0230 hours, Blackett Strait in the Solomon Islands. Lieutenant Commander Robert Kelly crouches in the cramped cockpit of PT-109, throttles pushed forward, 3 Packard engines screaming as his plywood boat charges through darkness toward a Japanese destroyer. The enemy warship displaces 2,100 tons of steel armor and naval artillery. Kelly's PT boat weighs 56 tons, most of it plywood and gasoline. His offensive armament consists of 4 Mark 8 torpedoes, weapons designed in 1926 that run too deep, detonate prematurely, or simply fail to explode on impact roughly 60% of the time. His defensive weapons, twin 50 caliber machine guns and a 20 mm cannon, might as well be slingshots against the destroyer's armored hull. Kelly fires 2 torpedoes at 800 yards. Both miss. He fires his remaining torpedoes at 400 yards. One runs erratic. One hits the destroyer amidships and fails to detonate, bouncing off the hull with a hollow clang that echoes across the water. The destroyer's searchlights snap on, illuminating PT-109 like a moth pinned under glass. 5-inch naval guns swivel toward the tiny plywood boat. Kelly slams the throttles into reverse, white water churning as the PT boat claws desperately away from certain destruction. This scene repeats itself 47 times during July 1943 across the Solomon Islands campaign. American PT boats, supposedly the Navy's answer to Japanese naval dominance in shallow waters, achieve a collective success rate below 15% against enemy vessels. The mathematics are devastating. Each PT boat costs $400,000 to build and requires a crew of 17 highly trained sailors. Against these assets, the Japanese send destroyers and cargo vessels that shrug off torpedo attacks and return fire with weapons that turn plywood hulls into splinters. Senior commanders at South Pacific Force Headquarters in Noumea debate canceling the entire PT boat program. Without a solution, America's island-hopping campaign faces a critical vulnerability. Japanese destroyers, operating freely in the narrow straits between islands, can resupply isolated garrisons, evacuate threatened troops, and interdict American supply lines almost at will. What these commanders don't know is that 2,200 miles away, in a maintenance hangar on Tulagi Island, a 28-year-old motor mechanic who barely finished technical school is welding together a weapons system that violates 3 separate Bureau of Ordnance regulations. A system that Navy engineers will call recklessly dangerous and structurally unsound. A system that will sink more Japanese ships in 6 months than conventional PT boat torpedoes sank in the previous year. This is the story of the modification they tried to ban and the mechanic who refused to wait for permission while sailors died. To understand why John Malcolm's innovation proved so revolutionary, you must first understand the impossible tactical situation PT boats face in the Pacific Theater during 1943. The motor torpedo boat concept enters World War II with a romantic pedigree borrowed from coastal raiders of previous conflicts. Small, fast, expendable vessels that dart into harbors, launch torpedoes at capital ships, and escape before enemy guns can respond. The British used similar tactics at Zeebrugge in 1918. The Italians perfected explosive motorboats in the Mediterranean. The American PT boat represents the Navy's attempt to weaponize speed and audacity against Japan's numerically superior fleet. Reality in the South Pacific shatters these romantic notions immediately. The narrow straits between islands, the primary operating environment for PT boats, create killing zones where speed provides no advantage. Japanese destroyers equipped with radar and searchlights detect approaching PT boats at ranges exceeding 3,000 yards. By the time a PT boat closes to effective torpedo range, roughly 1,000 yards, enemy guns have already bracketed the target. The Mark 8 torpedo, a weapon developed during the interwar years when budget constraints dominated naval procurement, fails catastrophically under combat conditions. The magnetic detonators trigger prematurely or not at all. The depth settings run too deep for shallow draft vessels. Contact detonators crumple against armored hulls without exploding. Even when torpedoes run true and strike targets squarely, the failure rate hovers near 60%. PT boat crews fire 4 torpedoes per successful hit, and even hits frequently fail to achieve kills. The strategic implications compound the tactical failures. General Douglas MacArthur's island-hopping campaign depends on isolating Japanese garrisons, cutting their supply lines, and forcing surrender through starvation rather than direct assault. This strategy requires American control of the sea lanes between islands. But in mid-1943, Japanese destroyers operate almost freely during darkness. The famous Tokyo Express runs that resupply Guadalcanal, Kalimbangara, and Vella La Vella despite American air superiority during daylight. PT boats, supposedly the answer to these nocturnal supply runs, achieve marginal results at terrible cost. Between June and August 1943, South Pacific PT boat squadrons lose 12 boats with 89 crew killed or missing. Their confirmed sinkings during the same period: 3 Japanese barges, 1 cargo vessel, and 0 destroyers. Vice Admiral William Halsey, commander of South Pacific Forces, receives casualty reports and questions whether PT boats justify their resource investment. Each boat requires high-octane aviation gasoline, a precious commodity in the Pacific. Each crew requires months of specialized training. The boats themselves demand constant maintenance in humid tropical conditions that rot wood and corrode metal with relentless efficiency. Against these costs, the return on investment appears negligible. John Malcolm never intended to revolutionize naval warfare. Born in Pensacola, Florida in 1915, Malcolm grows up in a family that operates a small boat repair business serving recreational fishermen and commercial shrimpers. He learns practical mechanics by necessity, repairing outboard motors, patching hull leaks, and improvising solutions with whatever materials the Depression-era economy provides. When the Navy expands rapidly after Pearl Harbor, Malcolm enlists, hoping his boat experience qualifies him for something beyond swabbing decks. The Navy assigns him to motor mechanic school, training him to maintain the temperamental Packard engines that power PT boats. He scores adequately on technical examinations but demonstrates no particular brilliance. His instructors note satisfactory performance and adequate troubleshooting skills. In March 1943, Malcolm receives orders to motor torpedo boat Squadron 8, stationed at Tulagi Island in the Solomons. His duties involve routine maintenance, changing spark plugs, adjusting carburetors, replacing fuel pumps destroyed by contaminated gasoline. He works in a sweltering Quonset hut that serves as a maintenance facility, surrounded by the constant smell of high-test gasoline and marine diesel. It's unglamorous work, the kind of assignment that produces no medals and appears in no after-action reports. But Malcolm possesses one trait the Navy didn't test for during his training. He cannot accept watching men die because equipment doesn't work. After 6 weeks on Tulagi, Malcolm has witnessed 14-points boats return from failed attacks. He's listened to crews describe torpedoes that missed, ran deep, or hit without exploding. He's helped repair boats shredded by Japanese gunfire during attacks that achieved nothing. He's attended memorial services for sailors killed aboard boats that never had a realistic chance of success. On the night of May 8, 1943, Malcolm stands on Tulagi's pier watching PT-157 limp back to base with her stern torn open by destroyer fire. 3 crewmen dead. 0 enemy vessels damaged. He stares across the harbor at the damaged boat and experiences a moment of absolute clarity. The problem isn't the boats. It's not even the torpedoes, though they're certainly terrible. The fundamental problem is that PT boats carry the wrong weapons for the mission they're actually performing. Torpedoes work theoretically against battleships and cruisers, massive targets with deep drafts steaming predictable courses. They don't work against maneuvering destroyers in confined waters or against the unarmored cargo vessels and barges that actually constitute most Japanese traffic in the Solomons. What PT boats need isn't better torpedoes. They need weapons that hit what they aim at, weapons that damage or destroy lightly armored targets instantly, weapons that let crews engage and disengage before enemy return fire can saturate their position. Malcolm walks to the maintenance hangar carrying a flashlight and a salvaged Navy technical manual. He starts sketching, rough diagrams at first, then increasingly detailed drawings as the concept crystallizes. What if PT boats carried rockets instead of torpedoes? Not theoretical rockets requiring development and testing, but actual rockets already in production, already proven in combat, already available throughout the Pacific theater. 5-inch high-velocity aircraft rockets, the VARs that Navy Corsairs and Avengers fire against ground targets. Each rocket carries a 50-pound warhead capable of penetrating light armor and detonating inside a target. Each rocket flies straight to its impact point without the complex gyroscopic guidance of torpedoes. Each rocket costs a fraction of a torpedo's price and weighs substantially less, meaning a PT boat could carry dozens instead of 4 torpedoes. The concept solves multiple problems simultaneously. Rockets provide volume of fire, saturating a target area the way torpedoes never can. Rockets arm instantly after launch, unlike torpedoes that require hundreds of yards to activate. Rockets work in shallow water where torpedoes run aground. Rockets hit above the waterline where Japanese vessels carry minimal armor rather than below where destroyers mount armored torpedo blisters. But Malcolm's concept has one critical problem. Installing aircraft rockets on naval vessels violates Bureau of Ordnance Technical Order 4387B, which prohibits unauthorized weapons modifications on combat vessels. The regulation exists for legitimate reasons. Improper weapon installation can compromise vessel stability, create fire hazards, or interfere with existing systems. Unauthorized modifications lack proper testing, documentation, and quality control. Installing VARs on a PT boat without engineering approval and official authorization could result in court-martial for destruction of government property. Malcolm decides the regulation is less important than sailors' lives. He needs an accomplice, someone with welding skills and access to materials. He finds both in Chief Petty Officer Raymond Stokes, a 42-year-old supply depot chief from San Diego who served in the Merchant Marine during the 1930s. When Malcolm approaches Stokes on May 12 with sketches and a request for unofficial material acquisition, Stokes studies the drawings for perhaps 3 minutes. "This is completely against regulations," Stokes says flatly.
Malcolm nods. "Yes, Chief."
"You're asking me to divert government property for unauthorized weapons experiments that could get us both court-martialed."
"Yes, Chief."
Stokes looks up from the sketches. "How soon can you start building?" "Tonight if you can get me the rockets." They begin after midnight in a corner of the maintenance hangar screened by salvaged canvas tarps. The rockets come from a damaged F-4U Corsair written off after a landing accident. Stokes liberates 8 5-inch VARs from the aircraft before it's shipped back to rear area depots. The launch rails, the crucial component, require complete fabrication. Malcolm designs a simple system using steel pipe welded into a cradle that mounts to PT boat deck fittings normally used for securing life rafts. The rockets sit in the pipes, stabilizing fins holding them in position. The firing mechanism comes from salvaged aircraft electrical systems, a simple circuit that sends current to the rocket igniters when the boat's gunner presses a trigger. The engineering challenges prove substantial. Aircraft rockets expect to launch from platforms traveling 200 miles per hour through stable air. PT boats wallow in waves, pitch in swells, and rarely maintain steady course during combat. Malcolm must calculate launch angles that compensate for target range while accounting for rocket ballistics fundamentally different from torpedoes. He spends 3 nights running calculations with a slide rule and a high school trigonometry textbook borrowed from the base library. The mathematics aren't perfect, but they're close enough. On May 18, Stokes and Malcolm install the complete system on PT-59, a battle-damaged boat undergoing engine repairs that sits isolated from the main maintenance area. They mount 4 launching pipes per side, 8 rockets total. The installation is crude, welds that would horrify Navy inspectors, mounting brackets that violate every protocol for weapons installation. Nothing appears in the boat's maintenance logbook. Nothing gets reported to Squadron Command. At dawn on May 19, Lieutenant John Kennedy, PT-59's commanding officer, discovers the unauthorized weapons during his pre-repair inspection. Kennedy stares at the rocket launching system for a long moment, then at Malcolm, then back at the rockets. "Chief," Kennedy says carefully, "what exactly am I looking at?" Malcolm stands at attention. "Sir, Those are experimental anti-shipping rockets. Kennedy walks around the installation, examining the welds and mounting brackets. Does Commander Warfield know about experimental anti-shipping rockets on my boat? No, sir, the commander doesn't know. Kennedy tests one of the launching pipes, checking the traversing mechanism Malcolm fabricated. Does anyone in the entire United States Navy know about this besides you?
No, sir.
Not exactly. Kennedy turns, and Malcolm braces for the disciplinary action that will end his naval career. Instead, Kennedy grins. Chief, when can we test them? The unauthorized combat trial happens 3 nights later during a routine patrol in Blackett Strait. PT-59 carries its normal torpedo load plus Malcolm's rocket system. Kennedy doesn't inform Squadron Command about the modification. The official patrol report lists standard armament only. At 0147 hours on May 23, lookouts spot a Japanese cargo vessel, designated a medium freighter by intelligence estimates, steaming northeast toward Kolombangara. Kennedy closes to 1,200 yards, a range where torpedoes become viable but enemy return fire remains dangerous. He doesn't fire torpedoes. Instead, he orders Malcolm, who insisted on manning the rocket system personally, to engage with the experimental weapons. Malcolm sights down the launching pipes, estimates deflection based on his calculations, and presses the firing trigger. 4 rockets ignite simultaneously, tearing from their launch rails in gouts of orange flame that illuminate PT-59 like a photographer's flash. The rockets cross the distance to the target in 3.2 seconds. 3 hit the cargo vessel superstructure. Explosions blossom along the ship's deck and wheelhouse. Secondary explosions follow as the warheads detonate stored munitions or fuel. The freighter slews to port, flames spreading rapidly. Kennedy fires his remaining 4 rockets.
All 4 hit.
The cargo vessel, fully loaded with supplies for isolated Japanese garrisons, burns from stem to stern. It sinks in 8 minutes. PT-59 returns to Tulagi at dawn with empty rocket rails and jubilant crew. The celebration lasts exactly 30 minutes. At 0645 hours, Commander Thomas Warfield, Squadron Commander, personally inspects PT-59 and discovers the unauthorized rocket installation. Warfield's initial reaction borders on apoplectic. He convenes an immediate disciplinary hearing in the squadron operations hut. Malcolm stands at attention while Warfield catalogues his violations. Unauthorized weapons modification, misappropriation of government property, violation of Bureau of Ordnance technical orders, conducting unauthorized weapons testing during combat operations.
Each offense carries potential court-martial.
But Lieutenant Kennedy intervenes. Commander, my boat sank a Japanese freighter last night. First kill for this squadron in 3 weeks. We fired 8 rockets, achieved 6 hits, and destroyed the target in under 10 minutes. Our torpedoes couldn't have accomplished that.
The room falls silent.
Warfield looks at Malcolm, then at Kennedy, then at the mission report documenting the confirmed sinking. How many of these rocket systems can you build? Warfield finally asks. Malcolm considers. With help from the machine shop and adequate materials, maybe 1 complete system every 2 days, sir.
Start building.
I'll handle Squadron Command. By June 1943, Malcolm and an expanded team of mechanics install rocket systems on 7 PT boats in Squadron 8. The results prove immediate and devastating.
June 4th, Kula Gulf.
PT-162 with Malcolm's rockets engages a Japanese destroyer at 900 yards, firing 12 rockets in 2 salvos. 4 rockets hit, destroying the destroyer's bridge and forward gun mounts. The destroyer, unable to navigate or return effective fire, beaches itself on Kolombangara's coast where aerial bombardment finishes the job.
June 19th, Blackett Strait.
3 PT boats equipped with rocket systems intercept a 4-ship Japanese convoy, 2 cargo vessels escorted by 2 destroyers. The PT boats ignore the destroyers entirely, concentrating rocket fire on the unarmored cargo ships. Both freighters sink. The destroyers withdraw rather than face weapons that hit instantly and repeatedly. July 12, Ferguson Passage. PT-157, the same boat Malcolm watched limp home damaged in May, uses rockets to destroy 2 Japanese barges and damage a third at ranges where torpedoes would have been useless. By the end of July, PT boats equipped with Malcolm's rocket systems achieve a 68% success rate against Japanese vessels, compared to the 15% success rate of conventionally armed boats. The statistics cannot be ignored. Rear Admiral Aaron Merrill, commander of Task Force 39, requests immediate installation of rocket systems across all South Pacific PT boat squadrons. But the Bureau of Ordnance in Washington reacts with bureaucratic horror. Malcolm's modification lacks proper engineering analysis, stress testing, or safety certification. The rockets aren't designed for marine environment corrosion. The launching systems violate structural load specifications. On August 2, the Bureau issues Technical Order 4387B Revision 3, explicitly prohibiting further installation of aircraft rockets on PT boats pending comprehensive testing and evaluation. Commander Warfield ignores the order. So do commanders of Squadrons 6, 9, and 11. By September 1943, over 40 points boats throughout the South Pacific operate with illegal rocket installations. Navy investigators arrive at Tulagi in October to enforce compliance with Bureau of Ordnance directives. They find a squadron that has sunk more Japanese vessels in 4 months than any other PT boat unit managed in the previous year. Vice Admiral Halsey, reviewing the statistics and the Bureau's complaints, makes a pragmatic decision. The Bureau of Ordnance can complete its testing and issue official modifications when it's ready. Until then, rocket-equipped PT boats will continue combat operations. Official authorization arrives in January 1944. The Bureau of Ordnance releases technical specifications for the Mark 50 rocket launching system, a refined version of Malcolm's improvised design featuring corrosion-resistant materials and standardized mounting hardware. By March 1944, the Navy produces factory-installed rocket systems that equip PT boats throughout the Pacific Theater. The impact on Japanese operations proves catastrophic. Tokyo Express destroyer runs, once routine despite American PT boat patrols, become unsustainably dangerous. Japanese cargo vessels require heavy destroyer escorts that cannot guarantee protection against rocket-armed PT boats. Supply lines to isolated garrisons collapse, accelerating the strategic isolation that characterizes MacArthur's island-hopping campaign. Post-war analysis quantifies Malcolm's contribution. Between June 1943 and August 1945, rocket-equipped PT boats sink or damage over 300 Japanese vessels, compared to fewer than 80 sinkings achieved by torpedo-armed PT boats during the same period. The rocket system directly influences post-war naval development. Modern missile patrol boats, from Israeli Sariar-class vessels to Norwegian Hawk-class fast attack craft, trace their conceptual lineage directly to Malcolm's innovation of mounting anti-ship missiles on small, fast platforms. John Malcolm musters out of the Navy in October 1945 with the rank of Chief Petty Officer. The Navy awards him a letter of commendation for innovative contributions to weapons development. The citation carefully omits any mention that his innovation began as a court-martial offense. Malcolm returns to Pensacola, resumes operating his family's boat repair business, and refuses all requests for interviews about his wartime service. When the Naval Institute asks him to contribute to their oral history project in 1962, he declines, saying simply that he fixed engines and helped install some rockets, nothing worth documenting. He dies in 1987 at age 72. His obituary in the Pensacola News-Journal mentions his Navy service in passing and focuses primarily on his 40 years in the marine repair business. But the lesson of Malcolm's improvised rocket system endures throughout naval warfare. Sometimes the most critical innovations come not from laboratories or engineering departments but from mechanics who watch sailors die using equipment that doesn't work. Sometimes the greatest act of courage isn't following procedures but recognizing when regulations matter less than results. Malcolm never sought recognition because he never saw himself as an innovator. He saw himself as a mechanic who fixed a problem using available tools. That the problem was tactical doctrine and the tools were unauthorized weapons simply made the job more challenging. Thousands of Japanese supply ships burned because one mechanic refused to accept that PT boats couldn't be effective. Thousands of American sailors survived because one chief petty officer decided regulations could wait until after he stopped the dying.